Let's start it. It's solving two equations and two unknowns. Remember this from your algebra days?
Yeah.
What do you do when you have two letters, two equations like that? How do you find x and y?
Cross out y and x.
Yeah, if you add them up, it's called the addition method. It's also called the elimination. You add them up, and 1x and 1x makes 2x. 1y minus 1y, they're just gone, huh? 8 and 2 makes 10. So far, so good. Then how do you solve for x? Divided by the 2. X is 5. Now we have x. Now we just plug it in to find y, huh? So x is 5.
Then that's 3.
Plug in x is 5. Wherever you want. Either equation, doesn't matter. I'll just grab the first one. X plus y is 8. Plug in the x is 5. 5 plus y is 8. Subtract 5. Y is 3. We got the answer is 5, 3. They want like, oh no, they don't. They just want the 5 and the 3. Okay, that's all they want. There we go. Good? Easy, huh?
Easy.
You knew that before I did it, right? Okay, so how do you solve there for x and y? Can you all see that okay? So 2x is 12, x plus 2y is 0. What would you do first?
Take care of the 2x.
Yeah, look at that top equation. It's just like easy peasy, right? 2x is 12, divide by 2, x is 6. So this time I'm just going to say, look, that first one only has x. I can just solve that first one for x. So x is 6, and then what do?
Then you plug that into the next one.
Then you plug that into the other equation, huh? Yeah. So now I go, okay, x plus 2y is 0. Plug in that 6. 6 plus 2y is 0. Subtract 6 from both sides. 2y is negative 6. Divided by 2. Y is negative 3. And we're done. Got x, got y. Easy? Can I move along? Yeah. All right. Okay, so 2x, right up here, 2x plus y is 9. 10x plus 5y is 14. This time, if I add them, nothing good's going to happen, huh? You don't want to, because don't write this down, but right, you ever see that? If I added them, I just get 12x, 6y, right? 1y, 5y, 6y, and something, 23. That's of no use to me because nobody dropped out, right? You need somebody to eliminate. That's why it's called elimination. You need to make the x's drop out or the y's. It doesn't really matter which one, but somebody's got to go away because I can't do two letters at once. I need one of the letters to drop out so I can solve for the other one, huh? So that didn't work. I shouldn't add these. That worked great on number 1, but it's not going to work here. Right, see why number 1 that worked so well? Because the y's, whoops, I'm erasing them. The y's were already opposites, weren't they? Plus 1y, minus 1y. From the beginning, they were opposites. So I added them and they canceled, they eliminated. So that was great. But that's not the case here. The y's are not opposites, the x's are not opposites. So what do? Before you add them, you got to make them opposites, huh? You got to make them opposites. So I've got to take that top equation and I've got to multiply through by negative 5. Everybody see how I'm coming up with negative 5? Because negative 5 times 2 will make that negative 10x, which is the opposite of the positive 10x. And then when you add them, they'll cancel.
Wait.
Everybody seeing that?
Well, you're canceling two variables.
Yeah, that's the little surprise. Yep, and we'll see that happen. So minus 10x, minus 5y, minus 45. That's a minus 5 there. The bottom equation, I'll just rewrite it. Just bring down the bottom equation. And now add them up. And I was hoping to just get x to cancel. It does, but so does y. 0 plus 0 equals minus something. 31, I think it is. Because that's minus 45 and positive 14. Anyway, what does that mean when both letters cancel out?
That are the same number?
When you get something like 0 plus 0 equals a number that's not 0, that means no solution. That's no solution. So that's no solution. That means there's no x and y that can make both those equations true at the same time. There's no way it can happen. There's no x and y that make that happen.
Can you choose multiply the top by negative? Wait.
No.
No, it's all
20.
just -5.
Instead, when you get 0 plus 0 equals 0,
Oh, no.
which we're going to get in a minute probably, that means infinite solutions. And we'll talk about that in a minute when we get to one of those. But I just want to let you know in advance, there's two things that can happen. You can get 0, 0 equals a number that's not 0 like we did, right? Something that's not true. 0 plus 0 does not equal negative 31. That is not true, no solution. You just no, not true, no solution. But if you get something like 0, 0, 0, which is true, but it's still kind of weird, there's no letters, that actually means infinite solutions. So there's no answers to this equation. There's no numbers you could plug in for x and y that would make both those equations true. Graphically, those are lines. What do we know about those two lines?
They never intersect.
Those are two parallel lines that never intersect. Thus, they have no intersection point, no point that's on both lines, no point that makes both equations true. Does that make sense?
Yeah.
All right. So 2x minus 2y is minus 2, and 5x plus y is 13. Okay. So you got to make either the x's or the y's be opposites. It doesn't really matter which one. How about, just so we're all on the same page, how about we do the y's? The y's look easier to me. So my goal will be to multiply the top equation or the bottom equation, or sometimes both, just depends on the problem, do whatever it takes, to make the two y numbers opposites. And then you add them and the y's will cancel. Right? Right now it's negative 2 and positive 1 y. Right? I want to make those both be the same number, one positive that number, one negative that number, so that when I add them, they'll eliminate. And then I'll have only x, and I can solve when there's only one letter. Solve for x, plug in, get y, we'll be done. Make sense? So do whatever it takes to make those become the same number, one positive, one negative. Opposites. So what do we got to do? Bottom by negative 2, right? Oh, positive 2. Sorry, positive 2. Bottom by positive 2, positive 2, positive 2. Everybody see that? That'll make that bottom positive 2y, opposite of negative 2y. We good there? That'd be the easiest way. So then we'll get, the top equation doesn't change at all. Bottom equation becomes 10x plus 2y is 26. Add them up. 12x, y's cancel. 24. We're good?
Yep.
So then divide by 12. Divide by 12. X is 2. So what do we do once we have x? So x is 2. Plug in x is 2 anywhere you feel like it. It'll work anywhere. Grab that. I'll just grab that second equation, or first equation, I mean. And I usually just grab the first one. Doesn't matter. 2x minus 2y is minus. There's a lot of 2's there. Plug in a 2. Everything is a 2 here. So that's 4 minus 2y is negative 2. Subtract 4. Minus 2y is minus 6. Last step, divide by minus 2. Y equals 3. We're done. Is that good? Remember all that from algebra? Making those guys opposites? That's what you always do. And you could have done the x's. You could have made both the x's 10, right? You could have multiplied the top equation by 5, the bottom by 2. Made one of them negative. You have to make one of them negative 10, though. Right? Make one of the x's negative 10, one of the other x's positive 10, and they would have eliminated. We got the same two answers in the end. Doesn't really matter. Either make the x's opposites or the y's opposites so that when you add them, they drop out. Because we don't want two letters at once. We want only one letter. We can't solve two at once. We got to get somebody to drop out, right? All right, 6 it is. So, okay, so we have 8x minus 3y is 9. 12x plus 3y is 16. All right, so what should you do with those two? Yeah, they're ready to be added right now, huh? Those y's are going to cancel right now. So just go ahead and do that. Just add them up right now. So we get 20x, the y's drop out. What's that, 25? Divide by 20. X's, and then reduce that, divide top and bottom by 5 to reduce the fraction. 5/4?
Yep.
Bless you. So 5/4. So x is 5/4. Now, you have two choices. When you get a fraction for the first day, well, you can just plug it in. Yeah, I'm not going to mess around with anything fancy. Just plug it in. You could use a decimal if you want. Yeah, but it's whichever way you want to go. Yeah, I'll just grab the first equation. 8x plus or minus 3y is 9. Put in the 5/4. 8. Yeah, this is going to be kind of nice, actually. So I just plugged in the 5/4. Everybody good there? Am I racing ahead of you? Is that good? So what I'm doing? Put in 5/4. Yeah, Alexis. Oh, yeah, it doesn't matter. You mean like could I plug into the second equation? You totally could. Doesn't matter. Either equation's fine. So, okay, now what is 8 times 5/4?
That's 8 over 1.
8 over 1, huh? 4 goes into 8 2 times. Cross cancel. And then 2 times 5 is 10. Minus 3y is 9. Bring it up here. So 10 minus 3y is 9. Subtract 10. Minus 3y is minus 1. Divide by minus 3. Y is 1/3?
Yep.
That was easy.
Easy peasy.
All right, we'll move on. All right, 3 by 3. We call this a 3 by 3. 3 letters, 3 equations. The other ones were 2 by 2s. This is a 3 by 3. So we have to solve 3 equations with 3 letters. All right, that's a pain. So what are we gonna do? Basically, you got to get one of the letters to drop out because you don't want 3. You can't handle 3. So get one of the letters to drop out of both of the other 2 equations. So I'm just going to start with x. Why am I going to start with x? Because x is, there's just a regular x that's nice to work with. That's easy to work with. I don't want to start with something like 5x or 7z that's already got a number in front of it. That would be kind of a pain. I want to start with just like a plain x or a plain y or a plain z. So I'm just going to use the plain x. And what I'm going to do is I'm going to say, hey, I can eliminate that 5x below it if I multiply this top equation by negative 5. And make that a negative 5x, add to the 5x below it by x, right? See the game plan? And there's already no x here. So then I'll have 2 equations that have no x. I'll have 2 equations with only y and z. I will have boiled my 3 by 3 down to a 2 by 2. And then I can do what we normally do from there. Did all that make any sense? Eliminate x from all the equations. That's the plan. Eliminate x. It's already gone from the bottom equation. It never was there. So really just eliminate x from the middle equation. Use the top x like a hammer to hammer out the 5x and get it to go away. So multiply the top equation then by negative 5. That's a 5, although it doesn't look like it. Negative 5, negative 5, negative 5. So this, and this times negative 5. What do you get? Negative 5x plus, careful on your signs, plus 5y, negative 10. Bottom equation, or the middle equation, I mean, is 5x, minus 7z, huh? Put that over here. Minus 7z is 20. Top equation, negative 10. Is that good? Everybody see what I'm doing there? I multiplied the top equation by negative 5. So that now I can add the 2 equations and the x's drop off. And I get 5y minus 7z is positive 10. Everybody see that? So I took the first 2 equations, combined them together, and got a new equation with only y and z. Now let me add to that mix this one, which also only has y and z. And now I've got 2 equations with 2 letters. See how I went from 3 equations, 3 letters, to 2 equations, 2 letters? By eliminating x from everybody? Does that make sense? That's how you handle a 3x3. There will be a 3x3 on the next test. There'll be one by hand and one by calculator. So that makes sense how they do the by hand one? So you boil the 3x3 down to a 2x2 by eliminating x from all the equations. Now, you know how to finish this up. We've done 2x2s, right? 2 letters, 2 equations. We can do that. What are we going to do?
Multiply by -1.
-1, exactly. Make the top one or bottom, doesn't matter which one. Maybe I'll just make the top one, just multiply through by -1. And then I'll get, I'm running out of room here, negative 5y plus 7z minus 50. The bottom equation hasn't changed. Just bring the top one down, the bottom one down. Then add them up, bye-bye y's. This is 8z equals minus 40. We okay to there?
Wait, what?
Everybody see? So I just made the y's opposites.
You multiply -1 to 10 and you got 50?
Yeah, I did get minus 50.
Wow, that was amazing. Yeah, thanks. No, that's wrong. That's craziness.
Yeah, I almost died looking at
Did you?
Yeah.
Just from that. Divide by 8. And 0 over anything?
0.
0. 0 it is.
You scared me for a second. I was about to say
It's funny. I wonder where that negative 50 came from. All right, looked at a 5, I guess. So z is 0. So we got z. Now I got to get x and y. Now, here's where you're going to do something a little different. You're not just going to plug into the top equation. That wouldn't be smart.
To all of them?
Because the top equation has 3 letters. If I just plug in z as 0, well, it just has x and y, actually. It doesn't even have a z. I can't even plug z in there. I'm going to plug into something that only has z and one other letter. That way I can find the other letter. I don't want to plug in someplace that has all 3
And
letters.
then that way you can find another one. And then
Yeah,
you can do another one.
piece by piece, right? So how about, this one looks nice. How about 5y plus z equals 10? If I plug in there, you see, I can find stuff. So let me go to a fresh screen here. So you got to be a little careful. I'm sure you can figure that out. So we got z is 0. I'm going to plug into the 5. I'm going to grab this one. 5y plus z is 10. Plug in the 0 there. 5y is 10. Divide by 5. Y is 2. So we got y is 2, z is 0. Now you can plug it anywhere you want. Now I'll grab the top equation. And it's x minus y is 2. I now know what y is. It's 2. So add 2.
X equals 4.
X is 4. Got x, y, and z. How could you check and make sure you're right?
You plug them in.
Yeah, you could go back and everywhere you've got x, you put a 4, put a 4. Everywhere you've got y, you put a 2, put a 2. Everywhere you got z, you put a 0, put a 0. Make sure they're all true. 4 minus 2 is 2. 5 times 4 is 20. Minus 7 times 0 is 20. Yep. 5 times 2 is 10. Plus 0 is 10. Yep. Makes them all true, doesn't it?
That's like math detective work.
Good? Questions on that one? We got to take our test.